Hey guys, so we're going to be getting into week 3 of our distance learning, and we're talking about lines and angle relationships as well as triangles today. So the first thing we're looking at is line and angle relationships. So just something to remember. Parallel lines are lines that never intersect. Okay, they'll never cross each other. Okay, so parallel lines are denoted by these triangles off to the side. That's what tells you that you have parallel lines. Another thing that's helpful, parallel lines, I don't know if you remember, but the abbreviation or the symbol for it are those two straight lines. It almost looks like you're writing 11. Okay, a transversal. Transversal is a line that intersects two or more lines. So this line that I'm going over right now is originally in blue. I'm going over it in green. That's our transversal, because it's crossing and intersecting the line at two different spots. Corresponding angles. Corresponding angles are two congruents. Congruents also the same as equal. So two congruent or two equal angles that have the same position on the same side of the transversal. Okay, same position, same side of the transversal. We're going to look at that in just a second, but first let's look at this example. And it says, what are the two parallel lines? Well, we see the two triangles there, so we know it's line A and line B. We would say that they are parallel to each other. That's the symbol again coming back in that we would use. Line A is parallel to line B. Our transversal is going to be the line that's going through them. So that would be line T. You can see it's labeled right there. Okay, so then it says name 4 pairs of corresponding angles. So if we look at our corresponding angles, again, same position on the same side of the transversal. So same side of the transversal, we're looking over here or we're looking over here, but it has to be on the same side of it. Okay, and then when it says in the same position, it's saying if I look at these 4 and compare them to these 4, which ones are in the same spots? Okay, so 1 is in the same spot as 2, right? So angle 1 and angle 2. Angle 3 is in the same spot as angle 4 in the other set. So angle 3 and angle 4 are a set of corresponding angles. Angle 6 and angle 5 are corresponding. Same spot. If you notice in those two different boxes, they're located in the same positions. Bottom right-hand corner, bottom left-hand, upper right-hand, upper left-hand. Okay, and then the last one is angle 7 and angle 8 would be corresponding. Okay, so that's corresponding angles. Then when we look at alternate interior angles, what does that mean? Okay, this is two congruent. Again, congruent just means equal. Angles that are inside the parallel lines on opposite sides of the transversal. And I want to take a minute. Inside, interior. Opposite, alternate. It matches up. Alternate means alternating sides, different sides. Interior means inside. So they are inside the parallel lines on opposite sides of the transversal. So inside the parallel lines would be these 4 angles right there, right? They are inside the 2 parallel lines. So name the 2 pairs of alternate interior angles. So we know we're down to just 5, 7, 2, and 4, but then we also need to remember that they are the ones that are on the opposite sides of each other. So angle 5 and angle 4 are inside the parallel lines on opposite sides of each other. So angle 5 would be congruent to angle 4 or equal to angle 4. The other set is angle 2 and angle 7. Angle 2 is congruent to angle 4, or you could just say, I'm sorry, not angle 4, angle 7. There we go. You could just list them, angle 5 and angle 4, angle 2 and angle 7. You don't have to put that congruent symbol in between necessarily. Okay, but since they are equal, you can do that. Okay, so you can do it the way we wrote it up here, or you can do it the way I wrote it down there. So we looked at alternate interior. Now we're going to look at alternate exterior. The only difference, so they're still two congruent. Okay, congruent is this symbol. You could also say equal, which is obviously just an equal sign, but now they are outside the parallel lines on opposite sides of the transversal. Okay, so again, alternate still opposite, but exterior, now we're talking about outside. So the ones we're focusing on are 1 and 3 and 6 and 8. Those are the angles. We don't care about the ones inside the parallel lines anymore. We care about the ones on the outside. So the two pairs of alternate exterior angles. The first set would be 1 and 8. So we have angle 1 being congruent to angle 8. And then the second set is angle 3 and angle 6. Because again, outside on the opposite sides of the transversal, those are the ones that are going to be equal to each other. So angle 3 is congruent to angle 6. Okay? Now we have something called adjacent angles. Adjacent angles are two angles with a common vertex and a common side that do not intersect. So they don't intersect each other, they don't overlap on each other. Okay, so we would have this angle right here and that angle right there. They share a vertex, they have a common side, but they don't intersect at all. So let's look at some examples. Tell whether the angles are corresponding, alternate interior, alternate exterior, vertical, or adjacent. So for the sake of not having to spend forever writing these out, corresponding will be COOR, alternate interior will be AI, alternate exterior is AE, vertical will just be vert, and then adjacent will be ADJ. Okay, so angles 2 and angles 3. If you look at those over on the diagram, they are across each other, made with two intersecting lines. Those would be vertical angles. And if at any point you want to pause this, try all of these on your own and then check your answers with me, absolutely do that. That's up to you. Angles 4 and 5, they are inside the parallel lines on opposite sides of the transversal. So those are alternate interior angles. Angles 1 and 8 are outside the parallel lines on opposite sides of the transversal. So that's alternate exterior angles. 2 and 6. If you look at 2 and 6, they are located on the same side of the transversal in the same positions, in the same spots. So that has to be corresponding. Look at 3 and 7. Same side of the transversal, in the same position in those two sets of angles. Those would again be corresponding. Angles 3 and 6 are inside the parallel lines on opposite sides of the transversal. So alternate interior. 5 and 8, they are only made up of these two intersecting lines and they are on opposite sides of it. So those are going back to vertical angles, which we had learned before. 1 and 2, they have nothing to do with vertical angles. They're not on opposite. They're not inside the or outside the parallel lines. So those would actually just be a set of adjacent angles. Number 9, we have angles 1 and 4 made just by two intersecting lines, opposite sides. So those are vertical angles. Okay? 4 and 8, those are going to be corresponding. Same side of the transversal in the same spot. So those are corresponding. 6 and 7, same thing. They're going to be vertical because they are made up of two lines and they are across from each other. Vertical. And then 6 and 8, they are just next to each other. They share a vertex and a line. So those are going to be adjacent. Okay? So examples, find the measure of the numbered angles in the diagram. So how are we going to do this? The first thing, if this is 75, we know that vertical angles are all going to be congruent. So that means this is also going to be 75 degrees. Then from there, we have alternate interior angles. 3 and 6 are alternate interior angles. So I know that that also has to be 75 degrees. From there, I know that 3 and 2 are vertical angles. Vertical angles have to be congruent. So that would be 75 degrees. okay? Then from there you can say, and let's focus on angles 1 and 2. They make a straight line. So I know that a straight line has to add up to 180 degrees. So then I can do 180 minus 75. That gives me 105 degrees. So that means that angle 1 has to be 105 degrees. Well, angle 1 and angle 4 are vertical angles, so they're congruent. So that means 4 is going to be 105 degrees. 4 and 5 are alternate interior angles. They have to be congruent. So that's going to be 105 degrees. 5 and 7 are also vertical angles. They have to be congruent. So that's 105 degrees. There are a bunch of different ways you could have gone through and figured that out. A lot of different methods you could have used, but that's one of them. Okay? So then let's look over here at number 14. So for number 14, we first know that 125 and 6 are vertical angles. That means 6 has to be 125 degrees. 125 and 3 are alternate interior angles. They have to be congruent. So 3 is 125 degrees. 3 and 1 are vertical angles. So then I know that those are going to be congruent. So that's 125 degrees. Then I know that angles 1 and 2 are adjacent, but they also happen to create a straight line, so 180 degrees. So 180 minus 125 is going to leave me with 55 degrees. So angle 2 is 55 degrees. But since I know that angle 2 is 55 degrees, and I'm going to do it a little differently this time, angles 2 and angle 7 are alternate exterior angles, and they're going to be equal to each other. So I know that angle 7 is also 55 degrees. From there, I can say 5 and 7 are vertical angles, so they would be congruent. That's also 55 degrees. 2 and 4 are vertical angles, so I know that that would also have to be 55 degrees. Okay, so that's how you would do something like that. And then normally we would go through and we would say the measure of angle 1 is equal to 105. So I'm going back to 13 here. The measure of angle 2 is equal to 75. Measure of angle 3 is equal to 75. I forgot my degrees. Measure of angle 4 is equal to 105. And you would keep going through that. Same thing for number 14. You would go through and you would list all of those. Okay, you can do that on your own. Now we're going to get into triangle notes. So the sum of the angles in any triangle is always going to be 180 degrees. Always 180 degrees. And there's two ways we can classify them. The first way is by their angles. So we're going to start with that. So we have an acute angle. The way we classify or define what an acute triangle is, it means that it has 3 acute angles. So if I drew a picture of that, it can look a bunch of different ways, but that would be an acute triangle because all of the angles are acute angles. If you remember, acute angles means that they are less than 90 degrees. Then I have a right triangle. A right triangle means it has exactly one right angle and only one. Okay, and that would be denoted by the square in the corner somewhere. Then I have an obtuse triangle. An obtuse triangle has one obtuse angle. Okay, and that would be drawn something like that. Well, let me make that actually a little better. There we go. And you can see that that angle is an obtuse angle. Then we have an equiangular triangle. That's where all the angles are equal, or you can say that they are congruent, but they are all the same. Okay, so all 3 of those angles would be the same measure. So that's how we classify them based on their angles. When we look at classifying them based on their sides, there are 3 options here. The first one is scalene, and scalene means that there are no equal sides. Okay, so that would look something like that. None of the sides are equal. An isosceles triangle means that at least 2 sides are equal. At least is a key word there. So that could look something like this, where those 2 sides are equal. Last one is an equilateral triangle, where all 3 sides are equal. And that would look something like that, okay?